Hello, this is a presentation by Jamie Maddox. This presentation is about the NDP protocol, also called the Neighbor Discovery Protocol. This presentation will discuss how important NDP is in the networking world. This is for the Fall 2024 Network Systems class. The NDP protocol is the IPv6 equivalent to ARP, but has a few added features and security. For one, this protocol has MAC discovery and router communication functions. This package deal makes communication between devices much faster both in and outside of the network. To best show the advantages of NDP, we'll compare it with an older protocol, which could be considered its grandfather, ARP. ARP, being made for the old IP standard IPv4, only has two main features. These features are the ARP broadcast and response. While NDP has similar functions, it has the added benefit of allowing routers to communicate. ARP messages are confined within the network it's sent out in. In contrast, an NDP message can span networks. Finally, ARP is vulnerable to spoofing, which could be detrimental to the security of the network. NDP, though, is built with resistance to such hacking methods. NDP has a range of messages it can send out. These messages matter based on the machine using it, but some can use all message varieties. For example, a workstation won't use a router advertisement message, only the messages that ask for IP resolution. In contrast, a router has the ability to ask for IP resolution and send out router advertisements. NDP has 5 types of messages it can send. For the messages that help with router communication, there's the router advertisement, so a router can send out its information. To ask for a router's information, the router solicitation message is used, and the redirect message is to tell a host that another router would be a better gateway to use. For the MAC to IP resolution messages, there's only 2. Similar to ARP, a broadcast is sent out with the neighbor solicitation message, and a response is given to this broadcast with the neighbor advertisement. This slide is for miscellaneous features. Due to the sheer abundance of features and things that NDP can do, there wasn't any way I could fit them cleanly in the last slide. One of the added features is that NDP can notify when a neighbor is unreachable. This can inform a router to take another path, show a down machine on the network, etc. Next, when an NS message is sent to a neighbor, it can find if the sender and receiver have the same IP. This ties in with the last feature. NDP can eliminate the need for DHCP. Not only can the NS message find copied IPs, it can then resolve this error by changing the IP on the machine that sent the message. This is done completely by NDP. No need for manual change from a human or the DHCP server. With these added features, NDP has raised itself to another level above ARP. To conclude, I have some final thoughts on the NDP protocol. It's strange to think that this protocol's closest relative is the ARP protocol. They do serve similar functions, but NDP has so many added benefits and functions that it feels they are completely different. This really shows how much the IT industry can advance in such a short period of time. To conclude, I feel that NDP and the many other features of IPv6 will likely make it the next new standard. Its ability to resolve IP copies, eliminating the need for DHCP as a whole, by itself could make IPv6 the next new standard. But NDP has so many more added features. As advancements continue, the need for IPv6 will grow more and more in the industry. Its ability to streamline networks, resolve IPs, etc. will make it an eventual need to have for any network, though this transition will take time. As the new generation of networking professionals go into the workforce, they'll likely be the ones to bring in the new standard of IPv6.